Okay, our quiz was to graph this function out. See where I put the square. Apparently. Wait, yeah. Should have been out here, so I'm actually gonna do this one. But class did the other one, yeah, that's fine. But let's our procedure. And everybody did real well, got the intercepts right away. Okay? And had a little trouble with the long run behavior because it just comes down to understanding how to multiply sign up. Okay? But there are a couple other details and that can get a little bit confusing. So let's make sure we understand that. Okay, so remember, I really want you to write out that stuff. Because soon you're gonna really need to keep your wits together and write out that stuff. These little lines here just show you where these two things come from. They're more or less optional, but I recommend them. I recommend that it looks like this when you solve an equation this level. Okay, that's similar to the way you do absolute value. Okay, so I'll just use a few dots here because the solution to this equation is really easy, and the solution to this equation is okay. At this point, we know that we can begin to sketch our graph. So here, and put x equals 2 here. X equals -3 here. Now y-intercept equals 0. Write it out. Reinforce it. Get over here, get it locked the board. But ignore the physics over there. Okay, x equals 0. So we get 0 minus 2 y equals 0 minus 2 squared times 0 plus 3 cubed. And of course, arithmetic's easy to do. It's going to be 4 times 9, which is 36. Well, it's going to be negative 36, though, because no, it's going to be 36. Is 2 negative 2 squared. Okay. So what we get we have to y is 36 there. Okay, now behavior. Sometimes referred to as long run behavior. I'm just going to do as x goes to negative infinity, and then I'll just talk about what happens when x goes to infinity. As x goes to negative infinity, why is that? It's because you're going to let x go to negative infinity. It means you can let x be as big a negative number as you like. Now, if x is even negative 100, x minus 2 is clearly going to be negative, right? If x is negative 1,000,000, x minus 2 is going to be an even bigger negative number, right? There's going to be a negative number. And it's going to approach negative infinity. So x minus 2 squared approaches positive infinity, because if you square a negative number, you're going to get a positive number. Okay. Negative times negative equals positive, right? And it's that simple. You just got to determine whether this thing you're squaring is positive or negative. And then when you square it, it's going to end up being positive. Okay. Then as approaches negative infinity, x plus 3 approaches negative infinity. So x plus 3 squared approaches a cube, sorry. X plus 3 cubed approaches what? It approaches negative infinity. Because you're cubing a negative, meaning you're multiplying a negative by a negative by a negative. And when you multiply 3 negative numbers, you get a negative number. So we can draw this arrow here. It's going to the left, which is toward negative infinity. And it's going down, which is toward negative infinity. Okay? Negative infinity in the x direction, negative infinity in the y direction. Also, the negative infinity we get in the y direction is a lot bigger than the negative infinity we get in the x. Because we're cubing this huge positive number, we get this unbelievably humongous. So we're cubing this huge negative number, we're going to get this unbelievably humongous negative. It's going to go down a lot after it goes over. Okay, well, you similarly reason out what happens as x goes to plus infinity, but that's pretty easy because everything goes to plus infinity. Okay, x is a big positive number. X minus 2 is a big positive number, and so is x plus 3. And then so is any power or any product of powers of x plus 2. So I'm not going to say too much about that, except it should be fairly obvious. But you do want to reason this out. Now, the other thing that we tend to neglect is the 0 here is quadratic. Or a 0 of multiplicity 2. Okay? I'll use the word quadratic because we know this quadratic or square function. We're very familiar with the way it behaves near its vertex. So this is going to act a whole lot like the vertex of a quadratic function. At this point, this is cubic 0. Its multiplicity is 3. Make sure I'm recording. Okay. And then, of course, we have our y-intercept. Now, how does a function act near a cubic 0? Near a quadratic 0, we're going to have something like this, right? Or maybe it's upside down. Cubic 0, it's going to act like the cubic function. And it's going to flatten out. Now, I didn't make that one quite flat, but it gets completely flat just for an instant when it goes through this point. Okay, so it comes up here, and to the left of the point, it is below the axis. but it gets so close that it looks like it's running along the axis. And just for an instant, it is exactly parallel to the axis. And then to the right, it stays really close to the axis. It finally it goes up and maybe it goes up here, should get come down here. And then goes through this point. Has a quadratic sequence. So there is a pretty good representation of the graph. Now, as I've said repeatedly, you don't know exactly where this peak is going to be. You don't know if it's going to be to the left or right of the x-axis. It could be either. And there's no good way to determine that analytically until you know the calculus. It doesn't take very much calculus to be able to determine exactly what that point ought to be. Make an even better graph. Okay. Now, that should give you everything you need to do a good job with graphs and polynomials. Okay. But let me just do one more. Okay, let's say now I give you a graph. I don't have a scale on this graph. What do you want x to be at this point? Just give me some use numbers since we have it recording. 5, it's going to be negative. Okay. So we're going to say, okay, here x is -5. Then what factor would give you what looks like a quadratic 0 at x equals -5? Okay, be a square. Square of what function? Well, this would be a square comes from an x plus 5 squared. Because if you get your x squared graph, which vertex is at the origin, right? If you want to shift it left 5 units so that the vertex is at x equals -5, you're going to have an x plus 5 squared. And that just goes back to the fundamental White transformation. Okay. Now, I will say that on the test we had in my class, people had pretty much lost most of what they knew very well, 6 weeks ago about transformations. And as I said in that class, it comes down to lack of review. Okay. And a lot of people did do well in the test who have done well day to day. It comes down to lack of review. So we've got to work on that. Okay, anyway, x plus 5 squared. Okay, so what's this going to come from? First of all, you're going to have to make an estimate of what x is here. So what do you think x is? 2, 3. 3. Okay. Okay, so if x is 3 here, what kind of a factor are you going to have from this? It's going to be q. Okay. So can you write down, I wrote down an x plus 5 squared here. What's this from? Go ahead and write it in the paper. Because right now it looks like you're sending smoke signals. Very, very nicely done smoke signals. But it's a little complex to try to gesture this. Okay, unsurprisingly, that we just wanted to make sure. You say that was from x minus 3q. Okay. Uh, What do you want extra equal here? That much. Okay, 7. That's about right. That looks good, like that is. Okay, so here x equals 7. Now, what's this come from? Well, I'll just tell you, it's not squared or cubed because it's going straight through. Okay, this is just from minus 7. It's their function. Okay, so now our polynomial estimated polynomial is y equals e of x for polynomial. And that's going to be, we're going to use an a out here because it's some multiple. We haven't got a vertical scale yet. Okay, y equals a times x plus 5 squared times x minus 3 cubed times x minus 7. Okay. Now, if we want to find a, what information do we need? We need the coordinates of some point. If I've got the coordinates of some point on this graph, and I can put the x in the y, I can solve for a. Okay. Tell me what x, y is for one point. That gives you the scale of the whole graph. Okay. So let's pick a point. Where I like to pick a point is blind. Okay. Can't see a thing. Okay. I think I hit right to. I was aiming for this point, so I was that far off. But if I hadn't been blindfolded, I'd have missed it by miles. Okay. And cooked. Okay, so let's just say that if I go to the nearest point to this one, that would be about here. Okay. So what's the x coordinate of this point? No, what's the thing? It was a little too much. You're saying 8, but it's kind of fuzzy. So we're going to say 7.5. I think 8 is a little too much. Actually, let's see, 1 would be about this. I'd say, well, we'll go with 7.5. No, what's y? You pick any number at all for y because we don't have a y scale here yet. So we'll pick a number for y. 3. Now it's -3, right? not gonna bother solving, because that's so easy to solve for A, and I won't insult your intelligence by doing it. Okay? Everything here is a number except A, so you can easily solve this equation, and then you can plug the equation back in, and you have a formula for the function. Okay? If you can do those two things, then you have a pretty good handle on, a good enough handle on polynomials. You're gonna do just fine on the questions I ask on the midterm regarding polynomials. Okay? So that's all we're gonna talk about polynomials. Now I want to do a separate video here that's specific to my class, since everybody in here is in my class. Okay, take a quiz. Okay. So we're going to stop this video